Hi student, welcome in chemistry classes. Now we are studying about coordination compound. The topic is crystal field splitting in octahedral complex. Okay, in our previous video, we have studied about salient feature of the crystal field theory. Based on this concept, now we have discussed crystal field splitting in octahedral complex. Okay, student, in D subshell, this is all 5 d orbitals are degenerate. Okay, so dxy, dyz, dzx, dx square, y square, and dz square. So this during the crystal field splitting, the two set is possible. This one is T2G. So another one is EG. So what do you mean by T2G? That means triple E degenerate. Triple E degenerate. That means all 3 d orbitals in same energy level like dxy, dyz and dzx. It is the same energy level. So this T2G set we have pronounced by T2G. Okay, and then also in the above. So this dxy, dyz, dzx are for the lobes lying in between the axes, like that. Lobes. It is in between the axes. X also y. It is like dxy. It is in between the axes. So the energy is decreased. The repulsion is very less. So the energy is decreased. Okay. Now you see another set. It is EG set. We have pronounced by EG. Okay. EG set of orbital. This EG set of orbital is doubly degenerate. That means two set of d orbitals in a same energy level like dx square and dy square, also dz square, also same energy level. So these orbitals in the lobes lying along the axis, that means directed towards the axis via through the ligands and the central metal ion. So the repulsion very high. The repulsion very high or strong repulsion, the energy is increased. That means a greater energy you compare to the dxy, dyz, dzx orbital. So these are the some crystal field splitting for the more important the point. So based on this concept, okay, now we have split crystal field splitting in octahedral complex discuss. Let us see the diagram. You see, first all d orbitals. So dxy, dyz, dzx, dx square, y square, dz square. So degenerate. That means free metal state. That means ground state. Okay, all 5 d orbitals for the degenerate state level. Now we get for the when a ligand approach to the central metal ion, when a spherical field is a form, that means average field. So little bit rise, increase the energy. Here also same, but it is called average energy. 1, 2, 3, 4, 5. It is also average energy. Energy of all 5 d orbitals. It is the average energy of the all the 5 d orbitals. That means spherically crystal field. Now this 5 set of the d orbital split into two energy level. One is a higher energy level, another one is a lower energy level. You see. So these 5 set of the d orbitals split into 2 set of energy level. So it is a low energy level, it is a high energy level, because the energy is always increase. This is energy. So the energy always increase. So here 3 set of the d orbital in a low energy, another 2 set of the d orbital is a high energy. It is called T2G. Here also it is called a EG set of orbitals. T2G and then EG orbitals. Here also T2G. Okay, that means dxy, dyz, dzx. It is also T2G set of orbital. Also T2G. Here also dx square minus y square dz square. This also EG set of orbitals. Now the splitting into these two sets, it is called crystal field splitting in octahedral complex. Total crystal field splitting in octahedral complex are pronounced delta O. It is delta O. That means O means octahedral complex. Delta means crystal field splitting energy of octahedral complex. Now this two set also we have subtract. It is a average. It is called 0. It is called barycenter. This energy. Now here two set energy we have the separate. Here the energy is increased by plus 3 by 5 delta naught. Here plus 3 by 5 delta 0 for the EG set of the energy level, but here the energy is decreased by minus 2 by 5 delta naught. That means also plus 0.6 delta naught, also minus 0.4 delta naught. That is a splitting of the d orbital in octahedral complex. So total energy scale the delta 0. Delta 0 means crystal field splitting energy in octahedral complex. Here dxy, dyz, dzs orbital, the energy is decreased by minus 2 by 5 delta naught, and dx square, y square and dz square orbital, the energy is increased by plus 3 by 5 delta naught. Here delta crystal splitting energy in octahedral. Octahedral. O means octahedral. So it is the main important the crystal field splitting energy of octahedral complex. Suppose now you take in D1 example for the D1 orbital, D1 complex. That means when a d orbital contains only one electron, we put for here the one electron for the ground state, so it is called D1 state. Also here also D1 state also. Now we are splitting into two energy level. The one electron present for the here. Okay, one electron present for the here. So we can write for the electronic configuration for the D1 complex. Okay, here T2G, one electron is present. So electronic configuration equal to T2G1, EG0. That is simple. We can write for the electronic configuration. Based on this configuration, lot of calculation is possible. Okay. So another one example. Suppose in d orbitals contain d2, 2 electrons are present. So 1 electron, 2 electrons are present. So here also 2 electron also present. So here also 2 electron also present. So we can write it is a d1 electronic configuration, d2 electronic configuration equal to T2G2Eg0. So you can write 3, 4, 5, 6, 7, etc. Up to 10 electrons we can write. Suppose we can contain D10. When D at first contain the D10, that means that 10 electrons are present. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electron also present. Here also we can put for the year. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in D10 configuration, the electronic configuration equal to T2G6 because 2, 4, 6. T2G present in 6 electron. So T2G6 and Eg4. This 4 means here 2 and 2. So 4 electrons are present in Eg orbital. So these are the crystal field splitting, and also you can calculate for the energy. So we can one formula is present. We have discussed that later for this formula. Suppose